Hi everybody, this is Alex Gorbunov from Intero Visuals. I've got another video tutorial for you. This time I will show you how to animate ceiling fan for your interior projects. I will show you how to do that without using any keys on a timeline. We will do that with expressions, and we will also use Bones system to create wobbling effect on the ceiling fan. That's the effect that occurs naturally with the fans that become unbalanced over time, and I think that will add a nice extra touch of realism to your visualization projects. Here's another example of what we will be making, so let's go ahead and get started. Reset 3ds Max so we can start working with nice and clean interface, and open first file from the project folder. What you can see on your screen is a model of the ceiling fan as one object. We will have to detach different elements of this model into different objects because we are going to animate them separately. And also, we will have to apply proper animated deformation to this rubber joint at the top of the ceiling fan. So let's go ahead and break this object into the separate elements. Go to front view. On the modify panel, go to elements of object mode. Now, in order to make detaching of the fan blades easier, we are going to use rectangular selection. That obviously will select a little bit more. Then deselect what you don't need, hit detach button, and name detached object into fan blades, hit OK. Now let's also rename remaining object into fan body, and that will just make navigation a little bit easier. So we ended up having two objects in our scene. This is the fan blades and the fan body. Let's also reposition the pivot point of the blades. Go to hierarchy panel, click affect pivot only button, and use align tool to align the pivot point of this object to the center of itself. Hit OK. And now we have a pivot point of the blades aligned to the center of the blades along z-axis. That just has a little better appearance. So now do the quick test. Just rotate the blades on the screen. If everything moves nicely with no errors, we're ready for the next step. You can continue with your current scene, or you can open second pre-saved file so that you can be sure we are on the same page. What you will see in the file is the same thing you just saw 15 seconds ago. It's two objects, fan blades and a fan body. Let's go ahead and select and hide the blades and concentrate on the body of the fan. We're going to insert bones into this object in order to apply proper deformation to it. So on the create panel, go to systems menu and click bones button. We're going to create the system that will consist of 3 bones. Start slightly above the object and do your best creating bones along the center of the object. Start second bone where the rubber joint is supposed to be, and make another mouse click slightly below the bottom end of the ceiling fan. Then click right mouse button to exit from bone creation mode, and here you can see we've created our 3 bones system. Later we will attach the geometry of the fan body to the system of the bones, and any deformation applied to the bones will be transferred to the geometry of the fan. Now let's align everything. Select bone number 1, use align tool, and tell it that you want it aligned along X and Y axis, pivot of the bones to the pivot of the object. Click OK. Now go to front view, and here we can adjust the positioning of the bones. For that, go to animation menu and choose bone tool. Now on a dialog that will show up, choose bone edit mode, and now we can manually slightly reposition each of the bones. So just select what you need to move and move it in the front view. Once you do that, let's switch to left view and double check everything over there. And let's also adjust the vertical positioning of this joint between bone 1 and bone 2. If everything looks good, exit from bone editing mode, and there you go. We've finished creating of the bones and positioning them so they go directly through the middle of the object. So we're ready for the next step. Again, you can continue with your current scene, or you can open next pre-saved file so that you can be sure that we're looking at the same thing on our screens. So once you open the file, or even if you're working with your current scene, and on Display tab of the command panel, in Display Color Rollout, switch from Material Color to Object Color. It will just make further working with this object a little bit easier because we're not distracted by all the materials. Now it's time to attach the geometry of the body of the fan to the bones system. That can be achieved by applying physique modifier to the deformable object. So go ahead and on Modify panel in the list of modifiers, choose and apply physique modifier. Once you apply it, you need to initialize it. So in Physique Rollout, hit Attach to Node button, and in the viewport, click mouse button over the first bone in our bone structure. That would be bone 001. Once you do that, Physique Initialization dialog will show up, and we need to change couple parameters before we hit Initialize button. So on Blending Between Links drop-down menu, choose two links, and switch from deformable to rigid in Links assignment group. Hit Initialize, and now we've initialized our physique modifier. An indicator of that would be those few orange lines that go along the bones. You will see them in the wireframe mode. Now you can see that if I select and move bone number 3, some of the vertices of the object are following along bone number 2, and some of the vertices are staying attached to the bone number 1 at the top, but some of the vertices are deforming at the place where the joint is between bone number 1 and bone number 2. That's pretty much what we want. It's just that we need to adjust the settings of physique modifier so that more vertices are attached to bone number 2 and less vertices are deformed at the joint between bone number 1 and bone number 2. All of that can be adjusted at the envelope subobject mode of physique modifier. Basically, envelopes are the virtual containers that define how much vertices of the deformable object are affected by any individual bone. There are inner envelopes and outer envelopes. Inner envelopes are displayed by the green color on your screen right now, and all the vertices there are enclosed in the inner envelopes are rigid. They will move along with that envelope. There are also outer envelopes displayed by the darker color on your screen, and all the vertices of the deformable object that enclosed in between the outer and inner envelopes, they can also be affected by the other envelopes that can be attached to the other bones. So basically you can control how much your deformable object is affected by each of the bone by adjusting the size and the placement of the envelope that is attached to that bone. Or more correctly speaking, the envelopes are attached to the links, and links are created once you initialize your physique modifier. But in our case, links are superimposed with the bones, so basically in our case it's the same thing. So let's go ahead and adjust the size and the shape of the envelopes that attach to the bone number 2. That can be done by controlling the cross sections of the envelopes, because each envelope can have cross sections that control its shape. So on the Modify panel, click cross section button and you will enter into cross section editing mode. Now using the selection window, select the cross sections. As you can see, I'm selecting on my screen, and using the scale tool, just scale them up, and you will see that immediately some of the vertices assume in green color. That means they are getting enclosed into that envelope, and as I move the bone they will be affected. Now we need to also increase the size of the envelope near the area where the electric motor of this fan is, and there is no cross section there, which is not a problem because we can add a cross section. Simply on the Modify panel, click Insert button and choose the place where you want to insert that cross section. It will be inserted. So now, just like you did before, you can select that cross section and increase its size using the scale tool. So now all the vertices are properly assigned, and you can see that if I change the shape of the bone structure, they are moving along bone number 2 correctly. Now we also need to adjust the parameters of the joint between bone number 1 and bone number 2 so that the rubber joint on our 3D model is bending correctly. Right now, if I minimize the viewport and change the shape of the bone structure, you can see that that area is deforming, but it's deforming too much, so we need to adjust that a little bit. That can be done by changing the shape of the same envelope that we just edited, but we need a better display of how those vertices in that area affected. So on Modify panel, scroll down to the display group and click Shaded button, and that will show you in different colors how the vertices are affected by the inner and outer envelopes. In our case, that area is affected by 2 envelopes, one that's belonged to bone number 1, you can see it right now, we're not going to change anything there, and the one that belonged to bone number 2, that's the one we are going to adjust. So in order to do that, let's go ahead and go to cross sections mode and select very top cross section of the inner envelope and move it down a little bit, then go to control point and select very top control point and move it down. You can see that we slide in yellow color down, and that tells us how much basically everything that's shown in yellow color is affected by the inner envelope. Now select and move down a very top cross section of outer envelope and do the same to the very top control point of the outer envelope. You can see that we're sliding down this aquamarine color that shows us the area of influence of the outer envelope. We might need to reposition again that top control point of the inner envelope again just to get back that yellow color, and that's it. So as long as your result look somewhat similar to mine, we're done with settings for that area. Now let's just do a quick test to see if everything works correctly. Let's minimize the view and try to change the shape of the bone structure. You can see I'm changing it, and on the perspective view you can see that the rubber joint is deformed properly. So that's what we want, and we've done a good job there. And again, here in the front view you can see how everything works. The bone number 1 at the top stays fixed in space, and that part of the ceiling fan is fixed, and everything is deforming as I move bone number 3. So, and that's how we're going to animate this object. We're going to animate bone number 3, its motion in space, and the whole ceiling fan will be bending according to the bone structure, and if we need to move anything, we will move it by bone number 1. I also always recommend to do one extra step to check if everything works correctly, is to select bone number 1 and try to scale it up and down, and you can see that the geometry of the object also gets scaled up and down except some selective areas there at the top. That's because the envelope that belongs to bone number 1 is not enclosing entire geometry there. That's an easy fix. We're just going to select cross section there at the top part of that envelope and scale it up. So now if we repeat the test and select bone number 1 and try to scale it up and down, the whole geometry follows, so everything is good there. We're ready to go to the next step. Now, as always, feel free to continue with your current scene. Just unhide blades geometry or open next preset file from the project folder, which I'm gonna do right now. And what you can see on your screen right now is all our objects are in place. The blades geometry have a pivot point at its center, and the body of the fan is also rigged with the bones. So let's go ahead and attach blades geometry to the bones as well. Simply go to toolbar, click select and link button, and then click over your blades object and attach it to bone number 2. And now you can see that if I move around bone number 3, The whole geometry of the ceiling fan is following the deformation of the bone structure. So that's what we want, and we're done with the rigging of this object. Now it's time to animate different parts of the ceiling fan. And we're going to start with blades. We're going to animate blades with the expression controllers that will give us the great flexibility and actually real-time control over the speed and the direction of rotation of the blades object. So let's go ahead and start with applying expression controller to the proper axis of rotation of the blades object. Go to Motion tab of the command panel and expand rotation group. And we need to apply expression to one of those three axes of rotation, but first we need to determine which one is responsible for rotation of this object. That is not always intuitive, and because once you link this object to some other object, the axes are a little bit different. So there is a trick to do that. Just switch current coordinate system from view to gimbal and manually rotate blades object a little bit, and as you do so, look at the transform type in numbers at the bottom of your screen and see which number changes when you do that. So basically right now, as I rotate this object and visually rotation is correct, I see that number are changing for the y-axis. So that's the axis to which we need to apply our expression. So on command panel, on assign controller rollout, select Y rotation axis and click assign controller button. That will give you a choice of multiple controllers. Simply double click over float expression controller to apply it, and you will see expression controller dialog show up to confirm it. And from this moment, the rotation of this object along y-axis is no longer controlled by any keys of anything else. It's controlled by this expression. And to demonstrate that, you can see that if I try to rotate this object along y-axis, nothing is happening. At the same time, if I try to rotate it over x or z axes, I'm still able to do so. That's because our expression will only affect the rotation of this object along y-axis. And how exactly it's going to affect it, we are going to tell by building some sort of formula into this expression controller dialog window. So repeat after me and type the following formula. S, which is a built-in function for seconds, times pi divided by 180. Now that pi divided by 180 is going to provide us the conversion from the degrees into the radians, because here in expression window it received the rotation in radians, not the degrees. Now if I click evaluate button and try to play this animation, you will see that the blade starts spinning with the speed of 1 degrees per second, which is too slow. So we need to introduce one variable through which we can control how much faster our blades will spin. So that variable will be called speed. Let's go ahead and insert it in our expression, like you see I did in expression group. Then once you did that, on the left side, go ahead and create the name of that variable and hit create button to create it. Now we can assign it to any fixed value for the test. Click assign to constant button and choose, for example, 90. That means now if I hit evaluate button and click play, our ceiling fan blades will rotate 90 degrees per second, or per every 30 frames of our animation. You can see that. Or for example, if we change the value from 90 to 360, hit OK, hit evaluate again, click play, the blades will spin faster. Now the good thing about expression is that there's no any keys. If I change the time settings of my current scene and increase number of frames to 300, for example, I don't need to rekey anything. The ceiling fan blades will spin with the same speed at any frame of my timeline. So let's bring speed value back to 90 degrees, hit OK, re-evaluate the expression, and you can close expression controller dialog. That speed value is gonna stay fixed for now for the sake of tests, but later we will bring it outside and we'll be able to control it interactively. So for now, let's move on and concentrate on animation of the body of the fan. You can see what we're trying to get there is to achieve that wobbling motion, because obviously every ceiling fan eventually in its life gather a little bit more dust over one of the blades, or maybe become disbalanced for some other reason, and as it rotates it will wobble a little bit. So we need to simulate that motion by applying expression controller to our bones, and that's what we're going to do next. But let's continue with next interim file from the project folder, because I just want to make sure that we are on the same page. Once you open that file, let's hide blades object, and let's also hide the body of the fan object, because right now we need to concentrate on the bones system. We will need to animate the motion of the bottom bone, which is the bone number 3, but we cannot directly apply any controllers to the bones, because even Autodesk does not recommend that. That will give us unpredictable results. So first we will have to create inverse kinematic chain, which we will apply to our bones, and then we can animate it. So let's go ahead and do that. Select bone number 3, and while you have it selected, on menu go to Animation, IK Solvers, HI Solver, click it, and then choose bone number 2. Once you do that, you will see that you've created inverse kinematic link between bone 3 and bone 2. You'll also see this big blue cross at the bottom. That's called goal. And if you move that goal, you will see that now the bones between which the inverse kinematic link was created will try to follow that goal. So that's how we're going to animate the motion of the bones. We're actually going to animate this goal. Thus we will animate the deformation of the bones. But before we apply any controller to the goal object, we need to take one extra step and add a little thing to this. See, the problem is that if I try to move my bone system by bone number 1, it's deforming because the goal of IK chain staying fixed in space. So we need to make sure that if I move bone number 1, the goal will also be moving. So let's go to Create Panel, Helpers menu, and create dummy object. So go ahead and create it in perspective view, then align it to bone number 1 using the Align tool. So align it pivot point to pivot point along X, Y, and Z axes. Now maybe adjust the size of the dummy object if needed. Now on the toolbar, use Select and Link tool and link bone number 1 to the dummy object, and then link goal to the dummy object as well. And now you can see that if I select and move dummy object, I'm actually moving my bone system along with the goal. And if I unhide all the geometry of the fan, of course it will follow the placement of the dummy object too. So in future, if we will have to move this whole structure, all we will have to move is just our dummy object. So let's hide the geometry of the fan back and keep working with animation of the goal. It's time to apply an expression controller to it. So again, like we did for the blades, go to Motion Panel, and on this IK goal position group, select this whole position parameter and click Assign Controller button. Then on Assign Position Controller dialog, double click Position Expression Controller to apply it. And again, like before, you see Expression Controller dialog, which by default have just the coordinates of our goal object. So we need to replace that with the formula that will dictate the motion of the goal object over time. So let's go ahead and instead of first number before the first comma, type the following: radius times cosine from S. Now after the comma, instead of second number, type radius times sine from S. And after the third comma, instead of the number, type 0. In this expression, radius is a variable, so obviously we need to declare it and assign some value to it. So let's go ahead and type in its name on the create variables group and click create button to create it. Now we need to assign some constant to that variable. Click assign to constant button and let's choose 10 for now. Hit OK, evaluate this expression. Well, what you can see happened is that now our goal object is a little bit higher than it was a couple seconds ago. That's because number 0 at our expression, at the end of our expression, is telling goal object to be at the 0 along z-axis, and because goal is linked to the dummy object, 0 means it's going to be at the same level. So we need to bring it down by changing 0 to something else. So let's try different number. Let's try -10, means we're gonna slide it down along z-axis 10 units. Hit evaluate, and obviously that looks a little bit better, but let's try number 15 and that looks even better. So we're good here, and let's continue. Click play button to see the results so far, and you see that our object moves very slowly. That's because current formula tells it to rotate 1 degree per every second of animation, which is slow, so we need to make it to rotate faster. So go back to your expression formula, and inside first parentheses, after letter S, insert times 360 times speed. Repeat the same thing for the second line of expression. And what's going to happen now is that we tell an expression that we want our goal object to revolve 360 degrees per every second of animation multiplied by the speed variable. So obviously we need to declare that speed variable, type its name, click create button, and again temporarily let's assign some fixed value to it. Right now let it be just 1, means 1 turn per every second. Click play to do a quick test and you see how it works. Let's try to increase that number from 1 to 2, and obviously it's gonna rotate twice faster. So that's good. Let's bring it back to 1 temporarily. Click evaluate to evaluate our expression again. And now before I close expression controller window, let me just quickly recap what happened here. We have our expression that controls how our goal object is rotating around a dummy object, and the distance of the goal object from the dummy object is controlled by variable radius, and the speed with which it rotates controlled by variable speed. So right now those both of those variables have a fixed values for the sake of test, but later of course we will make it to be possible to change those parameters in real time. So let's click close button to close the expression controller window. Click play animation button just to confirm that everything works fine. And now let's see how it works with the geometry of the fan unhidden. So click play again. You can see that all the geometry moves correctly. It follows the deformation of the bones. And what else is cool is that the rubber joint on a ceiling fan is getting deformed as the fan wobbles. So that's pretty much the effect that we wanted. So everything works perfectly. And now we're ready for the next step, where we will take our variables in the expressions and bring them outside so that we can control them in real time. Let's continue with the next pre-saved file so that we can be sure we work with the same thing. Just open the next file, and what you see there is everything is in place and everything is working. And this is our dummy object by which we can move everything. So we're going to consider this dummy object to be some sort of control center. We will add a few visual controls to it, and to those visual controls we can attach the variables from the expressions in this scene. So on top menu, go to animation and click over parameter editor. That will open up the parameter editor dialog, and that's how you can add visual controls to the modify panel. Actually you can add it to a few more places, but now we will concentrate on adding controls to the modify panel of the dummy object. So in UI type group, make sure it's set to spinner, and as a name, choose R-amplitude. That will be the name of the spinner by which we will be able to control how much the body of the fan will wobble. Now in the range group, let's change range from something like 0 to 30, so that wobble amplitude can only change within that range. Here at the bottom you can see a quick preview how our spinner will look, and once you click add button at the top, the spinner will be created on a modify panel in the custom attributes rollout. Right now it's not connected to anything, but later we will connect it to one of the variables of the expression that controls the wobbling motion of the body of the fan. Now let's create control for another variable of the expression. So go back on parameter editor dialog window. As a name, choose R-speed, and for the range choose something from -30 to +30, and negative numbers will make objects spin one direction, and positive numbers will make it to spin to another direction. Again, click add to add that spinner to the modify panel. And let's create one more spinner that will control the speed and direction of the rotation of the blades of the fan. As a name, choose S-speed, and for the range, again choose -30 to 30. Again, click add to add that spinner to the modify panel, and now you can also close parameter editor window. So what we have now is that we have created 3 spinners on a custom attributes rollout on a modify panel of the dummy object, and those will be the controls to the variables of the expressions that dictate the motion of the blades of the fan and the body of the fan. So all we need to do next is to actually connect those spinners to the variables in the expressions. So let's go ahead and do that. We will start with the blades of the fan. So just select blades object, then go to motion panel, expand rotation group, and double click on Y rotation controller. That will bring up expression controller dialog that has the expression that we've set up about 10 minutes ago. And you can see speed variable. If you remember, that speed variable right now have a constant number assigned to it. So what we need to do is replace that constant number with the connection between this variable and custom spinner that we've created on modify panel of the dummy object. So in order to make that connection, highlight that variable on the left side of expression controller window. Instead of clicking assign to constant, click assign to controller button, and you will see the tree with all available controllers in the scene. At the bottom, expand the objects branch. You will see your dummy object, expand that one as well. Then expand object branch, and you will see our custom attributes rollout. Expand that one too, and there you will see all of our custom created spinners. So choose the one that you need. In this case, this is going to be S-speed. When you highlighted that one, click OK. And let's also do one small correction in the formula. Remember before, as a speed, we used to set the amount in degrees that your object makes per every second. Now we are going to control it in number of how many complete turns this object is going to make per second. So after speed variable, simply insert times 360, and that will take care of that. Now you can evaluate your expression, and you can close expression controller window. Let's see how our blades work in action. Select dummy object, click play, and if I change number on a S-speed slider, the speed with which blades object rotates changes. If I use negative value, it starts spinning in another direction, and the higher number I go, the faster it spins. And the cool thing about using expression for that is that if I change number of frames in my animation, let's say from 1000 to 500, I don't need to rekey anything. There's actually no keys on the timeline. Everything stays the same. Now let's go ahead and create a connection between two other sliders and the variables of the expression that control the motion of the goal object. So selected goal object, then on motion panel, expand IK goal position group and double click over position controller. That will bring up expression controller window where you can see our expression that controls the motion of a goal object. So let's assign variables from this expression to corresponding spinners. First select radius variable, click assign to controller button, and you will see that on a track view window the path to our custom created spinners already remembered from the last time. Choose R-amplitude spinner and click OK to confirm the controller, and it will be assigned to the radius variable. Now let's go ahead and select speed variable, and again click assign to controller button, and on a list of available controllers choose R-speed, click OK to confirm, evaluate our expression, and you can also close expression controller window. So that's it, and we're ready to see how this all works in animation. Select our dummy object, hit play, and while animation is playing, on modify panel you can change any of these sliders. Like you can see I'm changing, and by doing so you will add wobbling motion to the body of the fan, and you can change the speed of the rotation of the blades of the fan. Let's change number of frames for this animation 2000, and like I mentioned before, you don't need to rekey anything, and just pick the parameters that looks good to you. You can make it wobble or spin faster or slower. Try different combination of parameters, see which one work better for you. I guess it depends of any individual project that you're working on. In some project you would want fan to spin a little bit slower but wobble more. In some other projects you would want it to spin faster but also wobble with a less amplitude. Okay, so now let's assign all of these objects into the group so it's easier to manage. Select everything and create a group. Let's call it ceiling fan. And in future, just merge that group from the file into your project. You can move everything by the group, or I would still recommend you though to open the group and move everything by the dummy object. Okay, we can close the group now. Let's also on display panel change the appearance of the object back to material color, and you can save the file now, and next time when you work with interior animation project and you need a ceiling fan for it, just merge it from this file and you'll be able to animate it in just a couple of mouse clicks. That's all. Thanks for watching. Don't forget to check our website and tell us what you think. Like our page on Facebook and follow us on Twitter. Again, my name is Alex Gorbunov, and I'll see you next time.